Okay, so let's put this sine wave on top of a loft, and you can see that I deleted the top one and the multiplication, so now we're just set up for a tractor for uh, one attractor. And basically the way that we're going to get this on top of a curve is we don't need those two things. First we need a curve, so I have these lines drawn in, so we're going to copy them and do a little loft, and we're going to set multiple curves. So we have a loft going on there, and we want to do surface evaluate, or evaluate surface maybe. Yeah, evaluate surface. And so the surface we're going to pass in is our loft, obviously, and then our UVs, we're going to pass in our UVs from our square grid. And you can see that they're clustered kind of weird over here. So we want to change these, we want to reparameterize this, and now you can see that they're flying off of our sphere or our surface in a weird way. And why that is when we reparameterize something, we want to pass in values in between 0 and 1 right here. So what we need to do is, I think the fastest way is just to shrink down our square grid. So let's do that by division, and get 1 over here. And this is the size of the grid cells. So now let's see if I can get this. Okay, so now it's making a grid just within that first unit. And so let's see what it's doing with our surface. This is giving us information at all these points, and yeah, so let's bump this up to about 36 or so. And now what we want to do is we want to have this value change the distance off of there. So the points we're going to be, we want to look at the points, and so yeah, so we have the points, and we want to move them in the direction of the normal by a factor of this. So we have the normal. To get a factor of our output, we need to multiply, and we're going to pass in the normals, and then we're going to add that right there. And is that giving us what we want? Yeah, it's affecting it some way, but we need to play with these a little bit. Okay, so looking at this, smaller values are working better, so let's make another slider that has a smaller scale to it. And you can see that it's all rippled, not out of the center or anything. So for this example, let's do that. Move the point to 0.5, 0.5, 0, so it's in the center. Okay, so now we have that shape. It's kind of interesting, and we're going to put those points into our mesh maker. Oh, that's wrong. So I think this is a really interesting application of using the sine and cosine, and you can make more interesting shapes by bringing in the same concept of multiplication of functions, sine functions or cosine functions or tritangents. I haven't really gotten tangents to work, but you can mess around with all sorts of things inside the Python component, and then also sorts of things outside the Python component, like maybe have the attractor, instead of having your attractor from the square grid, having it affect this, go by the surface points over here. That might be interesting. Let's try that. Okay, so we're getting something really funky right there. And that's probably because this is so far away, and then also this is really small, and amplitude, we can do something cool with it. But anyways, I wanted to give you a better example than just the basic one that you've probably seen before with the attractor and the flat sine. So play around with this and have fun with it.